Good day everyone, my name is Liz and I'm here to teach you and discuss about the balancing redox reaction and basic solution. Enthalpy, calculating the final temperature, and doing some learning and calculate.
Good day everyone. Now I'm going to help you how to solve the basic solution. Here is our given. NiOH2 plus N2H4, and for the product side, Ni plus N2. First, we must separate the elements into half reaction. This is the first element, NiOH2 and the Ni. For them to be balanced, we added a 2OH to the product side for it to be balanced at the reactant side. And now we have a 2 negative charge here. We must also add 2 negative charges here in the reactant side. And for the second element, N2H4 into N2, we added a 4 hydrogen here because in reactant side we have a 4 hydrogen for it to be balanced. And we have 4 positive charges here. For it to be equal to the reactant side, which is 0 charges, we must add also 4 electrons to the product side. And now we must times 2 the first element for the charges to be balanced, and we must cancel it out. And this is the second step. Now we have times 2 it already. This is the result. For you have 4 charges of electrons plus 2 NiOH2, and for the product side 2 Ni plus 4 OH. And for the second element, N2H4 for the reactant, and for the product N2 plus 4 OH plus 4 electrons. As we can see, we have 4 electrons here at the first element and 4 electrons also for the second element. Now we must cancel those charges for it to be balanced, and this is the final answer. 2 NiOH2 plus N2H4 and 2 Ni plus 4 H2O and N2. That's it everyone. Thank you.
One minute na.
Good day everyone. Today we're going to discuss how to solve a radioactive decay. First, you must go to the alpha. For the alpha emission, we add a 4 for the atomic weight and 2 for the atomic number. So first you must minus 4 the atomic weight, which is going to be 204, and minus the 66 for 2, which is 64. And now we must look for the element which has a number of 64 at the atomic number. So that element is the GD. For it to be balanced with the reactant, we must add the helium for the product. The helium has a 4 atomic weight and 2 atomic number. And that's it. It is balanced. And now we must go to the beta. For the beta, we add a 0 for the atomic weight and -1 for the atomic number. Now you will look for the atomic number which has a 85 for it to be balanced here. And that element is A, which has an 85 atomic number and a 209 atomic weight. We must include also this when we're doing a beta decay. And now we're going for the positron emission. For the positron emission, it is different from the beta decay. We're going to use a positive one instead of negative one. So we're going to add 0 plus 1 beta plus. Now we're going to look for the 110 atomic number in the periodic table, and that element is DS. DS, which has an atomic number of 110 plus 280 atomic weight. And also, we must also do this, but we will not include the negative sign at the top. So it will be just like that. And now, you will see all these three are all balanced if you're going to look at from the reactant to the product. And now we're going to the electron capture. For the electron capture, we are adding a beta to the reactant side instead to the product side. Like this. For it to be balanced. And now, you will just minus this for it to be balanced with the product side. So you will look for the 73 atomic number in the periodic table. And that element is A, which is stagnant. That has a 73 atomic number and 187 atomic weight. And now for the gamma decay, we have here given a 44 atomic number and 102 atomic weight. It is also similar to beta, but you will add a 0 y at the end. So it will be just like this. 0, -1 beta. Plus, you will look for the 45 atomic number in the periodic table. And that element is RH. Plus, we must also include the P. Yan. That's it for the radioactivity. Good day, everyone. Hello guys, today I'm going to teach you how to solve a carbon dating, and this is the problem.
And now here's the problem for our carbon dating. Scientists found a fossilized bone from an organism in a deep layer of rock. When they took the bone back to the laboratory, they realized that the bone had only 12.5% of the total carbon left. Based on the amount of the carbon protein left in the bone, how old is the bone?
Now we're going to solve the problem. This is the formula. So we must derive the formula for us to solve the value of K. And this is the formula. And now we must substitute the given. The given of Ln2 is constant. And now we have a carbon of which is 5,730 years. So we must include that here. T1 half, which is the 5,730 years. If we're going to divide that, Ln2 divided by 5,730 years, the answer is this. And for us to know how old is the carbon left, here's the formula. 1 divided by 1.21 times 10 raised to negative 4 per year, multiplied by Ln, 1 divided by 12.5%. 12.5% is a constant for the given. And this is the final answer. And now, we have the 17,185 years. And that is the old of the carbon.
Good day guys, today I'm going to teach you how to solve for the final temperature. We have a given here of 900 liters of palm oil at 47 degrees Celsius is mixed with the 200 liters of palm oil at 76 degrees Celsius. What is the final temperature? Assume that no heat is lost to the surroundings. So this is the formula guys for solving the final temperature. As you can see here, the top here, We converted the liters into grams, and now we're going to proceed for the formula. We're just going to do the FOIL method. We're going to distribute 180,000 to the 76 and to the x. Same also with the other side. And if we distribute the 180,000 multiplied by 76, its value will become 13,680,000. And for the x, if we distribute the 180,000, it will become 180,000 x. For the other side, if we're going to distribute the 810,000 to the x, it will become 810,000 x. And if we were going to distribute it for the 47, 810,000 multiplied by 47, it will be 38,070,000. And now we must transpose this 810,000 to the other side and 13,680,000 to the other side, and it will become like this: 180,000 x plus 810,000 x equals 13,680,000 plus 38,070,000. If we're going to add these two, we will come up with an answer of 990,000 x equals 51,750,000. And now we're going to just transpose this to this for us to calculate the final temperature, which is the x. Now we're just going to divide the 51,750,000 to the 990,000. And now the final answer is 52.3 degrees Celsius. And that's it for the final temperature. Thank you. Good day guys, today I'm going to teach you how to solve for the enthalpy. We have a given here of enthalpy problem. First, you must determine the amount of heat absorbed by a 50 kg of water to change phase from liquid to vapor. The heat of vaporization in constant is 2256 times 10 raised to 3 joule per kilogram. And we also have a constant mass, which is given 50 kg. So this is the formula for solving the enthalpy. We have a 50 kg mass and a constant of heat of vaporization at 2256 times 10 raised to 3 joule per kilogram. We're just going to simply multiply these two to get the enthalpy, and we will come up with the answer of 112,650,000 joules. That's it. Thank you guys.